Welcome back to the Scotti-BYTE channel, and this is Scott. So very often home lab configurations and self-hosted applications can be pretty difficult to implement. And sometimes when you search around the net, you just can't find good answers or any answers at all. And so this is video number 199 after about a little over 2 years of doing the channel. And in that period of time, I have spent hours and hours and hours trying to find topics to discuss that really didn't have good answers out there. And so today is kind of a good example of that same thing. And what I'm going to discuss is LXD virtual machines, not LXD containers. I've had a few videos on LXD virtual machines, but this time I'm going to talk about LXD virtual machines in conjunction with Netboot.XYZ. So Netboot.XYZ is a tool that allows you to boot your favorite operating system's installer or a live operating system, or also a series of utilities over the network from a simple menu system. And Netboot.XYZ uses iPXE, which is an open source network boot firmware and kind of an extension to the standard PXE, which is the pre-execution boot environment that allows computers to boot an operating system over the network. So iPXE can be flashed to your network boot ROM, or you can chain load into iPXE. And that's really what we're going to do today. We're going to chain load into iPXE from our systems, and we're going to go ahead and boot Netboot.XYZ. So although LXD virtual machines can be created from simple images, just like LXD containers are launched from images, and in fact that's what makes both LXD virtual machines and LXD containers very quick when you start them up, there's cases where being able to install a custom operating system or launch a custom utility is really great, and that's where Netboot.XYZ iPXE booting is extremely nice. Now that being said, a lot of people might hear this and say, well, hey, there's a great utility out there called Ventoy where I can just write a USB disk. And that's true, you can. But I think this is going to give just a little bit more flexibility, and you'll see why. To begin with, I'm going to show you the endpoint of what I've created here. And so what we're looking at is a startup of a container. And in this particular case, this container is called NetClient, and it is a LXD virtual machine. And I have it starting and displaying the console. So if I hit enter, it will go ahead and launch the console. I've just displayed a screenshot of the boot up of this LXD virtual machine because I wanted to talk about it. So this LXD virtual machine does have a hard drive associated with it, but this hard drive has been created and not initialized, and there's no data on it. So what ends up happening is that it says that it couldn't load the boot from the hard drive, the UEFI boot from the hard drive, and so then it goes ahead and continues to boot over PXE IPv4. And the very first thing it does is it says, okay, the DHCP server on your main network gave me the address of 172.16.1.194, and then it says that my PXE boot server's address is 172.16.1.99, and that's where I have Netboot.XYZ loaded. And we'll talk about that configuration later. But then it says that the netboot file name that it's getting is netboot.xyz.efi, so it's actually getting an EFI image as opposed to a legacy boot image. It's going ahead and downloading that image. It says it's downloaded successfully, and then it chains over to that image, and it is launching, it's chaining to the iPXE menu, and the menu it's going to fire up is Netboot.XYZ. And now what it does is it boots into the Netboot.XYZ menu. And up here we can see that it's counting down. When it gets to 0, it's going to try to boot from the local hard disk. But as we've already discovered, there's nothing on that local hard disk for this LXD Virtual Machine. So then we can go ahead and arrow down here to Linux installs, live CD installs, or Windows installs. I'm not really going to get into the Windows installs because this really isn't a video about Netboot.XYZ. It's a video on how you might be able to use this utility from within LXD VM and what it provides you. So I think the first thing I'm going to do is go off to this place under Tools called Utilities UEFI. And then in here we have a whole series of different tools. Just as an example, we'll go ahead and boot boot repair CD, and then it will go ahead and launch that boot repair CD. Now we're in boot repair, and normally boot repair is a utility that you use to fix your Linux boot up. In this particular case, though, we don't have anything on the internal hard drive. As a matter of fact, if we do an LSBLK, you're going to see that we have a device called SDA, and by default in Ubuntu, or not Ubuntu, but by default in LXD VM, you get a 10 gigabyte disk, which you can change, and we'll also review how to do that again. So we have SDA, it's not initialized, and it doesn't have any partitions on it. The other thing I can do is I can do an IP space A, and you'll notice that I have an address on my main network of 172.16.1.202. And normally what we do is we run a profile called bridge profile, and we bridge through the bridge 0 device back to the main LAN like we talk about in LXD step by step. But unfortunately, that requires a setup for an operating system to complete in order for that to occur. And here we don't really have any operating system at all. All we're doing is booting from the network. So let's go ahead and shut down this LXD, well, not really shut down this LXD virtual machine, but I hit the power off, and that power off got out of that particular utility. So I'm going to come back up and do a LXC console. Actually, I'll have to do a LXC start net client -- console equals VGA, and the reason for that is because the boot repair shut that machine down. So I go ahead and click that. It brings up the screen. If I do a view full screen, it's going to go back through that PXE boot process again. It's going to go access the Netboot.XYZ menu from the network. And there it is again. So we'll come down to Utilities. And this time I'm going to come down to RescueZilla. So RescueZilla is a version of CloneZilla with gparted and I think a couple of other utilities built into it. It's a really handy utility to be able to do backups and restores of disks and that sort of thing. So this installation of Netboot.XYZ will also work from your EFI booted machines, or your EFI booting machines, I should say. And I have that configured as well. So we'll go into that, but specifically, I really wanted to talk about what this could do in LXD VM. So this is the RescueZilla utility. You can say I want to back up or restore or clone something. And I can go ahead and minimize that screen. And of course, I have a terminal here. And when I bring up the terminal, it's going to be a regular Linux terminal, if it will start. There it is. And so likewise here, I can do my IP space A, and we have 172.16.1.202 here. We even have a web browser, so we can launch it. So now that I'm in here, I could, of course, open another tab, and I could go to Scotti-BYTE.com. And there's our favorite website. And likewise over here, I can go ahead and shut down that web browser and then come over here to Shutdown and say that I want to reboot. And it will go ahead and exit out again, but it hasn't stopped the LXD VM this time, so I can simply do LXD console net client --type equals VGA. And it will go ahead and come up and show me the Pixie boot once again. So we'll go ahead and enter the live CDs area. Go down here and find something interesting. Why don't we pick Elementary OS? And we'll pick Elementary OS version 7. When Elementary OS boots up, it's going to go ahead and ask us some initial questions. So I'll say we're English, United States, English US, and I'll just say default on the keyboard layout, and then go ahead and say try demo mode. And we'll go ahead and launch the demo mode, which is what most live CDs will go into. And of course, I'll let you do an installation from there. And just like we did previously, I can come up here to the power button, perform a shutdown, tell the system to go ahead and restart, and it will exit. And I'll come down here and say, show me the console again. And the console's booting back up to the Netboot.XYZ menu that's coming off of my local network. And then we can even look at our network card information, and it will tell us what IP address that it got when this particular instance of this LXD VM booted up. And it says what our next server is. And our next server is the server that is in the boot chain in order to boot up the Netboot.XYZ menu. And that actually comes from a TFTP server defined on my network. So what we need to do now is see how we build all of this and make it work. I'm on my LXD host name VMS Mist, and so I'm going to create a LXD container to host the Netboot.XYZ instance. So the command to do that will be LXC launch Ubuntu :22.04 netboot. Netboot will be the name of the Netboot.XYZ container. And I'm giving it the default profile, and I'm also giving it the bridge profile, as we've discussed many times on the channel before. And if you're not familiar with it, go watch the LXD step-by-step video. And then I have boot.autostart equals to true, which means that any time that the LXD host boots, the LXD server boots, then this container will start. And finally, I have security.nesting equal to true. And what that does is it goes ahead and makes sure that I can nest containers inside this LXD container. And we want to nest this Docker application. We'll go ahead and set up our netboot container by doing a LXC shell over to netboot. As soon as we get over there, we're going to do an apt update && apt upgrade -y. We don't have to use the sudo command because the LXC shell command puts us directly into the container in the root account. Now that our new container is updated, I'm going to go ahead and add a user account for myself with an add user Scott. Give Scott a password and verify that password. And then a user mod -A G sudo Scott, putting Scott into the sudo group. Since I want to have the capability to log into this container, I'm also going to do an apt install on open SSH-server. And there I can see that it's currently installed, and I know that the keys for this container are going to be stale, so I'm going to do an apt remove -- purge on open SSH server, followed by an install of open SSH server. So now I do an apt install open SSH-server, and now that it's reinstalled, it should be working fine. Now I'm going to install Docker from the Docker website script, and that's a curl of this particular script. Go ahead and provide my sudo password. Now that Docker's installed, I'm going to install Docker Compose with a sudo apt install docker-compose. And I'll go ahead and put the -y at the end, and it will go ahead and proceed to install Docker Compose. At this point, if I did a Docker PS, I would get an error because permission is denied. So I'm going to do a sudo apt or a sudo user mod -A G Docker Scott, adding Scott to the Docker group, and then I'll go ahead and do a new grp docker, and if I do a groups command, you can see that I'm in the Docker group and also the sudo group. At this point, if I do a Docker PS, I can get into the command without any privilege problems. Now that we have a LXD container with a working Docker, let's go ahead and do a make dir on Netboot, which is what I like to do when I install commands or install programs into Docker. And then I'll do a cd into Netboot and a nano on docker-compose.yml. And then I'm going to paste in my Docker compose command, which will be in the show notes. So at the beginning of this, we can see that the app is called Netboot.XYZ. Here's where the image is gotten from, and the container name is going to also be Netboot.XYZ. So I've set my PUID and GUID equal to 1001 because if you create a LXD container and then create your first user in it, that first user will have that 1001 for both the user ID and the group ID. And then I've put my time zone up to UTC because that seems to be convenient for booting Pixie. And then I have a local volume for config and a local volume for assets. Assets will be something we'll look at later on. That's if you want to download local copies of the things that you're booting from. And then very importantly, we have 3 ports, which I'm not changing because since a LXD container is dedicated to one particular application, I know that all the port numbers are free. But port number 3000 is the port that we're using for the web interface. Port 69 is for the trivial file transfer protocol, and that is the protocol that is used in order to Pixie boot because it has to load the software images from someplace, and TFTP is the protocol that's used. And finally, we have a web server running at port 80, which just has access to the particular elements or pieces that it will be downloading. And so that is also important. Once you've done all of that, we can go ahead and do a Control O and hit Enter to save that out, and a Control X to exit the Nano editor. And now the only thing left to do is do a Docker space compose space up -D. It's a very simple application. It will go ahead and pull the components and create the container and start it. Now that your Netboot container is up and running, the next step is that we have to go over to our router. And this is where things are going to differ according to which router you have. But in this case, I'm running a Ubiquiti Unify UDM Pro. I'm going down to the gear on the left side. Then I'm going over to Networks. And from Networks, I'm going to go ahead and select my main LAN because that's where I want to offer the Pixie Boot service. You might offer it on a VLAN, that's totally up to you. So then we scroll down on the page and there's an option for DHCP Service Management, Show Options. And under here, if I go down, there is an option for Network Boot. And Ubiquiti says boot a device over the network by specifying its address and the Pixie file server. So I go ahead and put a check mark in that blank. Now I had these values previously in here, but the address of the server that we just built, that means the LXD container that is running the Docker application for Netboot, is the address you should have here specified as your network boot address. In my case, that's 172.16.1.99. Finally, since LXD VMs don't like to boot from basically anything except for an EFI, they don't like to boot from the legacy boot, you can go ahead and put in here Netboot.XYZ.EFI, and when you're done doing all of that, in the case of my router, you go down here and say Apply Changes. And every router is going to be just a little bit different on how you set up those Netboot parameters, but that's just how it looks for this particular router. Here we are at the address of the Netboot LXD container, which is 172.16.1.99:3000, because you'll remember that we offered the web service on port 3000. And this is the main screen for Netboot.XYZ. They also have a menu screen where you can go out and configure your Pixie Boot menus. And then we have a local assets screen. So there is a capability to download it and have local copies of particular operating system boot files. And then what happens is that you can go ahead and boot locally without having to do a download off of the internet every time you do an install. So there's an upside and a downside. The upside of this is speed. The downside of this is, unfortunately, if you have local assets, it will only be able to boot those local assets. And those local assets can also become stale because they're not constantly updated, as are the public assets that are here on the left-hand side of the screen. So here we are on my local desktop, which is also a LXD server. And you could have created this next step here also on your, whatever your other LXD server is. It really doesn't matter. But this part is really kind of interesting. So what we're doing here is we're going to create a network with a LXD network create. And I'm creating a network called Boot Pixie. And it's going to be of type Mac VLAN. So you'll remember Mac VLAN is a protocol that allows you to put more than one MAC address on the same controller. So in this particular case, I'm saying Mac VLAN, and the parent is going to be a bridge called bridge 0. So it goes ahead and creates that network. Now, the reason that I did that is because when we do the next step, which is creating our network client will be created with LXC init net client, and it's a VM, as we said, because we have to boot Pixie through a VM. We can't boot a LXD container. And then it's a VM that's empty, which means it doesn't have any operating system images installed on it. Nothing is installed. And then the network is going to be the boot Pixie network that I just created in the command above. And then I'm setting my CPU to 2 CPU pseudo cores and 8 gigabytes of memory. So this 8 gigabytes of memory is very important, because if you're going to boot live CDs or live images for operating systems, as I demonstrated in the first half of the video, 8 gigabytes is a minimum because it needs memory in order to put the in-memory components that a live CD requires. And then I have security.secureboot equals false, because most of our Linux images are not signed images. So I go ahead and do that init, and we now have that device created. Now, one of the questions you might ask is, why did I simply not use the bridge profile in order to create this container, as I have on the channels so many times before? And the answer to that is because the bridge profile does work just fine, but the problem is it counts on an operating system getting installed to the disk so that it can interact with the LXD daemon in order to provide an address. But we need a really low-level support for our network, and by creating this network called boot Pixie and applying it instead to our container, as a result, we end up having a address on the main LAN that starts at the very beginning of creating the container, and so that will support the Pixie boot properly. The reason that I performed a LXC init as opposed to a LXC launch is LXC init does not start the container, it just creates it, whereas LXC launch starts it. And the reason I did that is because I wanted to show you another command, and that is this LXC config device override on net client, and I say root size equals 50 gigabytes. So just know that when you create an empty VM, the default size of a LXD Virtual Machine disk is 10 gigabytes. So you can use this override command to make that root size larger, and in this case I'm making it 50 gigabytes, and then that way I will have the option to install an operating system because I'll have enough space to do so. And now, finally, the way that we interface with this is I can do a LXC start net client, and I'm saying -- console equals VGA. When I hit enter, it goes ahead and starts that, and it brings up the remote viewer program. So the remote viewer program, I can go ahead and go full screen on it. It goes out and it gets the Netboot menu and it launches it. And once we have the Netboot menu, we can do anything that we wanted to do, as I showed in the earlier part of the video. So for example, we can go down here to live CDs, and I suppose I could go down and install a Linux Mint as an example. And let's go ahead and install Mint Live 21, and we'll do that with the Cinnamon desktop. So it goes off here and downloads the pieces it needs from the GitHub repository, and it begins the boot process. So now we've just booted the live installation of Linux Mint. And up here you'll notice that there is an install option. If we do that install option, we can actually point to that 50 gigabyte disk that we just installed. And we can have a LXD VM that is running Linux Mint. Of course, this is a little bit easier to do in a lot of cases if you just create a LXD VM, but not all LXD VMs have all versions of everything you might want to run. And this, of course, provides that, and that's really nice. So I can go through here and I can see what we've got when we get down to the disk section. I'll do a continue just to get to that point so you can see where the options are. And so it can say erase disk and install Linux Mint. So the disk they're talking about is that 50 gigabyte disk over there. And it should come up with a screen that calls out that disk and lets us know what it is doing. So in this particular case, it sees SDA1 and it wants to know if I want to write changes to the disk. And so it would go off and perform that function. I'm not going to go through the rest of the install, but it just works terrifically. So this really isn't designed to be a video on all the things that you can do with Netboot, certainly, but we do need to look at one other thing just so you can see how it's laid out. If we go to the menus option, and then we look down here for boot.cfg and click on it, and it comes up. You can go ahead and set this live endpoint here to be the address of your Netboot.XYZ server. So it would be HTTP. Let me go ahead and blow this up a little bit. It would be http://172.16.1.99 in my particular case. And if you had a port number on the end, you would put that. But that's the address giving the web location for the assets. So the only downside to doing that is if you come over here to local assets, you have to pull the assets required to do any particular operating system installation. So as an example, if we wanted, let's say, rescue Dilla, we would go down here or Rescue Zilla. We'd go down here and we would highlight all three of the Rescue Zilla pieces, and then we would scroll to the top of the screen and tell it to pull those selected images. Now, since we had made the change in the boot.config file, the only thing at that point in time that we could boot up would be Rescue Zilla, because anything in this left-hand column is not going to be reachable since we made our local server where the assets are stored. So in summary, Netboot.XYZ and Pixie Boot access to a boot server provides a way to support diskless booting. And Netboot.XYZ configured on your network provides options to access valuable utilities and operating systems and potentially install an operating system from scratch on a computer. So I showed how to configure a LXD VM to support Netboot.XYZ. And this is probably one of the easiest ways to learn the power of Pixie booting. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.